Yeah, I can hear you, madam.
Oh, okay, sir. So you just want to check your audio and video?
That's right. Yeah, yeah. I just wanted to see if when I'm sharing, I just wanted to ensure that maybe you can just do a trial run. That's right,
Yes,
madam.
sir. Yes, it's clear, sir.
Okay. So can I share my screen and can I show what can I show my presentation and can you just let me know if everything looks good?
Ah, okay, sir.
Yeah, just a minute, madam. So, but my audio is clear, right?
Clear, sir. Clear, sir.
Okay, thank you.
Audio, video, both is clear.
Okay. So, let's see. Ma'am, can you hear me?
Yes, sir. Yes, sir.
I think the browser is not responding now. Just give me a second. So
Okay, sir.
it's just saying Chrome browser not responding. I don't know why. I'll just close the browser and join again, madam. I'm not sure.
Okay, sir. Okay, sir.
Just give me a minute.
P Lab, Microprocessor Lab, Electrical Machines Lab, Electrical Machines Lab 1 and 2. Smart Grid, Digital Design Lab, Electronic Circuits Lab, Digital Simulation Lab, Linear and Digital Integrated Circuits Lab, LDIC Lab, Lab View, Process Control Lab, Mechatronics Lab, Dynamic Lab, IC Engines Lab, Center of Excellence Multi-Fuel Engine Setup, Center of Excellence Biodiesel Plant, Metrology Lab, Metallurgy Lab, CAD Lab, CAM Lab CNC Lathe, CAM Lab CNC Milling Machine, Boiler Turbine Setup, Robotics Lab, Heat and Mass Transfer Lab, Welding Lab, Machine Shop Lab, Fluid Mechanics Lab, Manufacturing Technology Lab, Fluid Mechanics and Machinery Lab, Fluid Mechanics Lab, Survey Experiment, Survey Camp, Strength of Material Lab, Concrete Lab, Soil Mechanics Lab, Structural Lab, Environmental Lab, Transportation Lab, CAD Lab, Biochemistry Lab, Autoclave, Microbiology Lab, DBT Research Lab, Tissue Culture Lab, Genomics Lab, Bioprocess Lab, Instrumentation Lab, Molecular Biology Lab, Downstream Processing, Physics Lab, Chemistry Lab, English Communication Lab, Research Lab 1, Research Lab 2, Lecture Hall, Computer Lab, Animation Lab, Computer Graphics and Multimedia, Chroma Studio, Advanced Java Programming Lab, Software Testing Lab, Web Technology Lab, Lecture Hall, Architecture Studio 1, Architecture Studio 2, BARC Computer Lab, MARC Computer Lab, Photography Lab, Workshop BARC, Workshop MARC, Workshop CRIT Room, Material Museum, Faculty of Medicine, College Block, College Lobby, Classroom, Anatomy Dissection Hall, Anatomy Histology Lab, Anatomy Museum, Biochemistry Students Practical Hall, Physiology Hematology Lab, Clinical Physiology Lab, Physiology Amphibian Lab, Pathology Morbid Anatomy Histopathology Lab, Pathology Research Room, Clinical Pathology Lab, Pathology Museum, Pathology Demo Room, Pharmacology Experimental Lab, Dispensing Room, Student Practical Lab, Museum, Animal House, Microbiology Practical Hall,
Warm greetings to all. I, Dr. Preeta George, welcome you all on behalf of our whole organizing committee. It's an honor to honor this beautiful audience to the 4th day of International Faculty Development, Multidimensional Scaling from Science to Technology, organized by the first year BTech E&S and Office of International Relations of Dr. MGR Educational and Research Institute, graded with special autonomy status. Why do we need FDP? What is FDP? Faculty development programs are set by the faculty, of the faculty, and for the faculty. And for the dear participants, attendance link will be rolled out in the live chat, and kindly fill it up to ensure our participation. Your queries can be posted and it will be addressed by our guest at the end of the session. No area of science is totally self-contained. Discoveries in one area find applications in other unpredictably. The universe is out there and waiting for us to explore it. When cloud computing combines with astronomical data, we can provide unprecedented economies of scale in personal data collection and management. A true welcome is never complete without warm words and warm gestures. I request Dr. Kannan from the Department of EEE to welcome the gathering. Sir? Dr. Kannan? Yes.
Yes, ma'am.
Yes, sir, you can.
Voice is clear.
Yes, it's clear.
Okay, ma'am. I am Dr. A. Kannan, Associate Professor, Department of Electrical and Electronics Engineering. First of all, I am giving my very warm good morning to all. First of all, I would like to thank our Honorable Founder Chancellor, Dr. A.C. Shanmugam, and our Honorable President, Engineer A.C. Arun Kumar, for giving this great opportunity to conduct this 5-day faculty development program. On behalf of Dr. MGR Educational and Research Institute, first year BTech Engineering and Technology campus, it is a great pleasure for me to welcome all of you having the 4th day of faculty development program on multi-dimensional scaling from science to technology in association with International Relations Office. I welcome Dr. S. Geeta Lakshmi, Vice Chancellor of our university, Dr. C.B. Palanivelu, Registrar, Dr. V. Cyril Raj, Joint Registrar, Academics and Administration, Dr. Nalluswamy, Joint Registrar, Inspections, Dr. D.B. Jabaraj, Joint Registrar, Dr. N.S. Subhasri, Dean E&S, and Dr. Kausalya, Coordinator, International Relations Office, to be with us today. We are fortunate to have on eminent speaker, Mr. Rajeshkumar, Senior Consulting Technical Manager at Oracle Financial Services Software, California, United States of America, to talk about leveraging cloud computing technologies to multi-messenger astronomy. His passion and knowledge towards cloud computing will make today's session very effective. We are honored to welcome you, sir, and I would like to extend my heartful welcome to all participants of this virtual event. Once again, I welcome all of you. Thanking you.
Thank you, Dr. Kannan. And
Thank you, Bhatta ma'am.
yes, sir. Thank you, sir. It's time to know about our guest speaker, and I request Mr. Manikandan from the Department of ECU to introduce our guest. Manikandan, sir.
My voice is audible? Hello?
Yes, sir.
Okay. Good morning. A very warm welcome, everyone, once again. Myself, Manikandan, Assistant Professor, EC Department, first year BTech campus. It's my great honor to introduce our chief guest of honor for the day, Mr. Rajeshkumar, who is currently a Senior Consulting Technical Manager at Oracle Financial Services Software Incorporation, California, USA. He has been completed his computer science and engineering degree from Madras University. He has already made a mark in the field of as an consultant for the past 20 years in the banking and financial institutions, helping them to implement banking products. He is a certified yoga teacher serving Fremont area, USA, and a passionate person about running half marathons, yoga and meditation, volunteering and music. He is a part of IGL team from the beginning and help IGL in music technology and educational initiatives. He always loved teaching and helping students. It's our proud privilege to have him as a chief guest. Thank you, sir.
Thank you, Manikandan, sir.
Thank you, ma'am.
Yeah. If your actions inspire others to dream more, learn more, do more, you are a leader. We are happy to have a great leader who inspires us. Among us, our Joint Registrar Inspections, Dr. S. Nalluswamy, and I request Dr. Nalluswamy to grace this occasion. Dr. Nalluswamy, sir.
Yeah, yes, ma'am. Very good. Very good morning to one and all.
Good morning, sir. Yes, sir.
Yeah, you
Yes,
please
sir.
continue, ma'am. I'll come in between. I'll catch you. You just
Okay,
continue.
okay, sir.
Yeah.
Okay, sir. Okay. Uh, Let us hear from our speaker, Mr. Rajeshkumar, about the fastest application running on the cloud and the future of astrophysics. The session is open to you, Mr. Rajeshkumar, and I request Mr. Rajeshkumar to take astronomy to the clouds.
Thank you, ma'am. Thank you, Preeta, ma'am.
Yes, sir.
Thank you.
Yes, sir. Yes.
You're able to hear me, right?
Yes, sir.
Can you see my screen, ma'am?
Not yet, sir.
One second, ma'am. Are you able to see the screen, ma'am?
No. It's loading, sir. Just wait. Yeah. Yes, sir. Yes.
Okay.
Yeah.
Good morning, everyone. It's a pleasure being among you in this wonderful morning. And thanks to the MGR Institute, thanks to the respected professors, lecturers, and the whole team of MGR College, and the team who have coordinated to make this whole faculty development program a successful one. And we are happy to be part of this program. Yesterday, Rajeshkumar sir was taking a wonderful session on multi-messenger astronomy. And today we are going to look at, in continuation to that, we are going to look at how cloud computing is going to help us in this multi-messenger astronomy. So again, thank you everyone. Thanks for the college team. Thanks to all the participants who are participating in today's session. Thanks to our IGL team members, Krishna Kumar sir, Kritika madam, for working tirelessly and make this happen. Thank you for the opportunity, sir. So here we are today to just learn about few things about how cloud computing can help address the challenges that multi-messenger astronomy, the field of astrophysics, is facing in today's world. So you must have heard yesterday from Krishna Kumar's session about what multi-messenger astronomy is about. So it's quite fascinating topic, right? So in this world, astronomy, a lot of improvements are happening in the astronomy, in the space world, and all the physicists around the world are trying to learn a lot about what is happening in the space, and how can we there is a, even from our ISRO, they did a Mars program, and a couple of weeks back NASA was launching a commercial flight to International Space Station, and they were trying to do a lot of experiments in the space to understand what exactly the whole space is around. So when the learning has become enormous in this field, and how do we complement this learning is what we are trying to help the scientists and astronomers actually around the world. So that is where the computing technologies like cloud computing comes into picture. So both are really a buzzwords today, astronomy, astrophysics, and cloud computing as well. If you just go out, whatever cloud computing is affecting every common man in today's world. I think this crisis situation, this COVID situation, has brought everyone to sit inside the house, and so we are trying to be productive in the house actually. So how are we being productive in the house is to learn many things as much as we, whatever the passion that we have, we are trying to go read articles about it. And everywhere there is a Zoom session, there are a lot of Google sessions and all those stuff. So how is it being enabled? All the Zoom sessions, all the video conferencing sessions, everything, the backbone of these sessions are all cloud computing. So cloud computing has helped the whole world actually to just it has improved the learning opportunities. It has given a gamut of possibilities, and areas to explore. So, and again, again, now when we talk about the astronomy with cloud computing, we are planning, we are exploring a lot of opportunities which can solve the daily challenges that the field is facing today. Yep. So so it's going to be an interesting session, and I hope you guys will also feel interesting and get some takeaway from this session, I believe. So thank you, one and all. Let's start the session. And yeah, I'm Rajesh, and I work in Oracle Financial Services. I've been working here in this company for the last 20 plus years. And yeah, so basically it's a data company where I work with. So every day in and day out, we see multi-petabytes and exabytes of data, and in the financial industry. So there are a lot of challenges in the data that we process on a daily basis. So how are we addressing it? How to make the raw data very meaningful? And only data can be in any format, right? So how to make it meaningful so that we can have an informed decisions, so that the business gets benefited actually. So end of the day, the business is the one which drives and which brings money, right? So data is the crux today, and and deriving some value out of the data is the information. So how do we get information from the data is what we are all about. And yeah, so I'm part of this industry, and it's been really exciting journey here with multiple tier 1, tier 2 banks, both in India as well as outside India. Yeah, and cloud computing has given us a lot of opportunities to synergize to synergize the banking industry with the cloud data actually. So how can we collaborate together, and how do we benefit the system, especially in this crisis situation when the budgets are quite low? This comes quite handy actually. And what are the challenges that the existing companies face, and how are we addressing those challenges is what we are trying to help the industry as well as the customers across the globe. All right, so let's go to the outline. So what I'm going to do today is we are going to just see what exactly is cloud computing. Actually, everyone is talking about cloud computing. How did this term come into picture? So all of a sudden, we know about computers, we know about normal computing. Why all of a sudden this cloud computing came into picture, and it has become a big buzzword today in the industry. Everyone talks about it. And what are the building blocks of this cloud computing actually? So what is it made of actually? So what are the advantages of having it? And how is it enabling the industry? How is it enabling the common man? So we are going to see that as well. And but the main topic today, we are going to address it. How is cloud computing going to help the multi-messenger astronomy actually? So yesterday's in the session, Doctor very clearly was mentioning about all the messenger signals that we get from the space. Initially, it was just the light waves that we were just seeing from the space, but now you have more than 3 to 4 messenger signals that we get on a daily basis, and it's numerous, like gravitational waves. You have neutrinos, you have solar waves, and in addition to the light waves. So measuring these waves, initially it was just telescopes, but later on, as the advancements were improving, we had new capabilities coming up, and that's how all these that's how the multi-messenger astronomy is all about. And so we are going to and there are challenges in these when measuring these waves from the astronomy, like when you get zillions and trillions of wave signals coming from space, we need to identify what kind of data that can be extracted, whether that is useful or not, or how much information that is carried in each of the signal. So we have sophisticated instruments today with us in the industry, and how are we going to decipher it actually? How are we going to read it how are we going to understand it, and how are we going to take it once we understand, then how are we going to make use of it for further enhancements and improvement in the field of astronomy. So LIGO India, which is which is part of this gravitational wave study a study organization. It's based out of Pune, I believe, and they are doing a phenomenal job in multi-messenger astronomy, doing a lot of experiments, a lot of postdoctoral studies, and a lot of research scholars there have published papers actually. So and yeah, and they are studying how high performance computing, how the big data, how cloud computing going to help us in all their experimental studies. So that is challenging, and they are towards that. They're moving towards what exactly how to make their experiments or to make their thesis going on live. So that is what their direction is. And so today we are going to show you what exactly, we are going to pick a small problem, and we are going to show you how cloud computing can help you in addressing this issue. So next we'll be addressing how the computing thing, how the storage, how the network. So these are the building blocks of cloud, and how the virtual machine instances, like how is the cloud computing, how is the cloud computing, excuse me, using the virtual machines to solve the solution. So there are popular cloud service providers like AWS, Microsoft Azure, and Google Cloud Platform. So they have multiple various services to address the issue. And we are going to take a look at it. We are going to take a specific problem and then see how these solutions can address the solution. All right, so what is cloud computing? So cloud computing is, by definition, it's just storing and accessing the data and programs over the internet instead of just your computer's hard drive. Excuse me. So the ideal example is Google Photos or YouTube that you watch on a daily basis. So you just take a photo from your mobile phone, and how exactly it gets stored is it gets stored in the cloud. It's a Google Drive. It gets stored, and whenever you wanted to access it, you can access it from anywhere. But previously that was not the case. But when these cloud things were not there, you have to, when you take a picture, it is stored in your either camera. You have to transfer it to your computer, and then you have to process it and then do the other stuff. So the initial, when you talk about how exactly these cloud things formed, it was all about sharing the infrastructure. Initially, when during the mainframe days, when multiple people could not afford to use the mainframe for their computing, they wanted to use the machine. They wanted to use the machine for their processing. So that's how the time sharing machine concept was there. And later on, how it got evolved is Amazon. Amazon is the one which pioneered in bringing this cloud computing forward, because when they had multiple in the US, they were just doing a online bookstore business as well as the online retail business. The demand was more a certain point in time, and then sometimes the demand was less. So the computing needs were more, and they were just trying to find a solution for it. So that's where they came up with Amazon Web Services, where they included multiple compute resources, and they were trying to address the demand that they had at certain point in time. And whenever it was not required, they were able to shelve them away. And they were one of the main pioneers in bringing the cloud computing to the in the front run. And later on, Salesforce was one other company which made all most of the CRM applications on cloud, and so they simplified the way software or an application is being used to the end user actually. So so basically, when you see in a typical data center you have today, you just work on any experiments, or within your college campus or within an institute, you have a data center. All your data is stored in a private within the data. You have a separate network, you have a separate storage area, you have a separate processing. But there are few instances which was posing challenges to it, and that is where the cloud computing. So when they termed it as, you just put, let us forget about where exactly all these things are stored. Let us just focus on what our main work is. So that is when that is where cloud computing came into picture, and so it is agnostic of where exactly the data is stored, and agnostic of where exactly the network and computing power is taken care by the vendors actually. How does this cloud computing work? So cloud computing work. So rather than a institute or a company owning the computing resources, we are just renting out all those resources so that someone can take care of it actually. So that is how cloud computing works. And one benefit of using cloud computing is the cost actually. So initially, initially what you have to do is, if you have to set up a data center, you need to invest in the asset, the data center, the servers. You need to invest on the software and everything. But when you just leave all these things to a vendor, so your cost is your capital expenditure is not is taken care, and all you have to worry about is the operational expenditure, and that is how and most of the companies, they like it, because they don't want to have all these capital expenditure in their balance sheet to be high. But as and when you have the demand, you can just, as and when you can just use the resources, and then the cost becomes less actually. It's kind of a pay-per usage is what the model is of the cloud computing, and that is how it became really famous. So for example, if you see the Netflix videos or Amazon Prime videos, so what you do is, you actually do not go there, and you're not seeing. So everything is online, everything is on cloud. You just, whatever the movie that you like to see, you just go open the browser, see what is the movie that you're interested in, and then you just pick the movie and then play it for you. So that is how flexible it is. And all these media companies, they're very much reliant on cloud computing, so that they can address the demand, and they can just add the compute resources whenever they need actually. So let us see how exactly the cloud computing is different from the on-prem world. So on-premise, if you see, the resources are deployed in-house with limited access actually. But in cloud computing, resources are deployed over the cloud, and you have multiple models of deploying it, like private, public, and hybrid. And the access is also wide. You have a wider access of accessing the data. And we talked about the cost as well. So the cost of in the on-premise is quite large. You need to shell out a lot of money for your infrastructure, as well as the software and the licenses part. But the operational expenditures, like maintaining the data centers, like updating the softwares, so that is quite huge when you go with the on-prem world. But in the cloud computing world, it is just about pay-per usage. So it offers on a monthly billing model. You just use whenever you want, and then otherwise you need not use it. And if you are a regular user, if you are constantly, there are a lot of discounts that the cloud vendors provide based on the usage that you do actually. and that is how the cost of the company it drastically comes down. And when you see the third part is the security part of it. Actually, the security inside in your on-prem world is highly controlled, and it is internally controlled actually. So you'll have a certain set of when it's in the on-prem world, you won't have the flexibility to address all the security protocols and the industry standards. It is complex, but though achievable, it is little complex. But in the cloud world, there are a lot of security protocols taken care, and a lot of whatever the geography compliance that the industry needs, that is taken care. And the kind of encryption algorithms and the kind of availability and the data security is being exponentially advanced. And previously, this was security was one of the main concern at the initial stages of the cloud computing, but now it has all come. It is we have the industry has overcome it, and you have a lot of methods to secure the data. You have multi-factor authentication. You have to secure the data, and so that even the financial industries, for example, they are moving towards the cloud. Because we work with a lot of banks, and all they wanted is it doesn't help them to get into a on-prem data center with shelling out more money, but they wanted to get into the cloud to reduce the cost. And they're quite convinced about the security of the data because of the latest technology that we have in the today is ensuring that the data is protected and it is private within the customer actually. And then it's the next one is about the availability. So availability in on-prem world is quite challenging because we are not sure when the demand for the compute resource and when the demand for the data, how the data storage and the network bandwidth increases. So predicting the demand and then providing resources for them for the oncoming demand will be challenging in the on-prem world. But in the cloud computing, it is quite opposite actually. So it's always available, and it is resilient for any natural disasters and external attacks. And scalable. Scalability is the other future where we talk about when the business is exceeding, when the business keeps expanding, the compute is more, and your compute demand for your compute is more, and it is hard to address them. It is so the cloud will actually help in the cloud will actually help in spinning up the computers. It help in spinning up the computers and servers to address the demand. So that is the other factor. And the last one is the maintenance. So maintenance is very when it comes to on-prem world, there's a lot of work involved in doing software updates and software maintenance. But in the cloud world, everything is programmed and it's automatic, and you can easily you need not worry about them, and it's easily taken care. So these are in a quite broader way are major differences between the on-prem and the cloud computing world. I'm sure you should have got some basic idea about what these two are actually. So coming to how the models are deployed, so there are various types of deployment models. Like public cloud, a private cloud, and hybrid cloud. So public cloud is all about it's open through internet. So it's quite scalable, and it's cost efficient, and you have unlimited storage as we saw here, and you can just keep spinning up the number of disks you want. And again, the cost wise, operational cost, or it's just like a pay as you go. For example, if you're just going to use just for a few hours in a day, you just have to pay only for that, not for the entire day. So it is that efficient as it is for in the public cloud. But few corporates and enterprises, they would not go with the public cloud. But when you have a private cloud, which is within the organization, it is single tenant. So the single tenant, in the sense, they don't share the resources with the other customers. So it's highly secure, is what highly secure, and it's highly flexible, because it is within their area. So they can dictate the terms, and they can take the decisions as they want and in their own speed, and it's fully customizable too. But in the public cloud, there are different variants of public cloud, and you just have to figure out which variant will suit the business. So when you combine these two, hybrid clouds are pretty famous today. So we are trying to take good in each of the, both in private cloud and the public cloud. So scalability, the hybrid cloud, what it takes is it's highly scalable, which is from the public cloud domain is what we take, and we try to ensure the security protocols is highly taken care, and the compliance standards are well maintained, and the flexibility as well, the flexibility of how to address the computing needs and the demand. So that is taken care, and in addition to it, it's cost efficient. So pay per usage is what it is, and unlimited storage is other one. So we are trying to take the advantages of both the public and the private, and hybrid has been widely prevalent now, and many customers and organizations are moving towards it. So the next one, we are going to talk about what are the different deployment models in the cloud computing. So the first one is about the basic IaaS is infrastructure as a service, and then the second one is a platform as a service, and then the last one is a software as a service. So these are the main deployment models when we talk about any cloud offering that we give it to the customer. So infrastructure as a service is nothing but we just provide the servers, the network, and then the storage. And the platform as a service is nothing but we give an additional kind of a additional resources for the customer, so that they can build on using the infrastructure as well as the additional resources. They can build their applications on their own. But software as a service is something quite unique. You just have to go use what the functionality the software offers, and then you just have to use it. And each one has got its own market share, and the software as a service is quite famous today, and the growth is quite phenomenal across the globe. And but uh, but parallelly, even the infrastructure as a service is coming up, and they're catching up the thing, because they wanted to do everything on their own. And what are the various providers of infrastructure as a service is Google, AWS, and Microsoft Azure. And software as a service, if you see, it's mainly Salesforce and Oracle SaaS, Oracle applications. And platform as a service, you have Red Hat, Redshift, and Elastic Bean, AWS's Elastic Bean, and you also have one from IBM product suite. So each one has got its own functionality, and it all depends upon the product. It all depends upon how the business requirement is, and so based on which the customer goes to which offering they can take, either as a software as a service, or as a platform as a service, or an infrastructure as a service. So when you talk about multi-messenger astronomy, how these things are going, so there are few companies which offer a software as a service specific to the scientific world. So we can use that as, so those applications can be used for the study of the space. And infrastructure as a service, what they provide is they're going to provide the complete infrastructure to you, so that you can build or you can build all your applications on top of it. So we are going to see that in the next slide, what exactly the real differences of each of these are actually. So here we have the complete difference about what on-prem world is, what infrastructure as a service is, what PaaS services, and what software as a service is actually. So you have so infrastructure as a service is infrastructure as a service. As we discussed previously, it gives the basic skeleton for the basic skeleton for you to build applications on top of it. Uh, so you know about the on-prem world. Actually, we talked about it in the previous slides. So it's all about the data center, how exactly what components it has actually. Like in on-prem, you have all the everything built in. Like starting from, if you just go from bottom to top, you have your networking infrastructure set. You have all your storage set. You have all your servers. Then you can virtualize the servers. Then you know what servers to run, what operating systems to run each of the virtual machines, and you know what the middleware, what are the application layer that has to be running, and the runtime components. And then finally, you need the data. Once everything is there, you have your data and the application sitting on top of it. But in infrastructure as a service, what the vendor provides is they just provide your basic infrastructure like networking, storage, servers, and virtualization. And what the customer they build everything on top of it. They build the applications, they bring the data, they use they choose which operating systems their applications have to be built, and they're both the middleware and then the runtime. But when you come to a platform as a service, so it is something like some additional extra features the vendors give it to the customer. So they give, in addition to the servers, storage, and networking, they give uh, they choose the operating system, they choose your middleware and the runtime. So all you have to bring only just your data and the application, and then you can you need not worry about what is underlying the infrastructure is. You can just install the application, ingest the data, and then you can just start working on it actually. So that is what all the platform as a service is about. And software as a service, as I said, it's just like it's a vanilla thing. So everything is ready. You just have to just go and use it actually. So you need not it's nothing to be nothing from your end actually. So everything is there, and you just have to start using it with your own data. Yep. And one parallel what I could think of is actually, for example, if you say, I was just reading in one of the journal, if you wanted to see a complete take a parallel or an example for it is uh, we can say is dosa as a service. For example, if you see, so on-prem world, it talks about making a dosa at home actually. So you have all the ingredients for you, just like butter, your toppings, your kitchen, your stove, everything is there at home, and you just make it. So that is your on-prem world. But if you go out and if you eat in a hotel like Saravana Bhavan or A2B, that's the software as a service. You just go there, you need not prepare anything. You just go have dosa and then just keep coming. That is the software as a service. Infrastructure as a service is something like you are just preparing your dosa in a service apartment. Maybe they just provide just the stove, they just provide the kitchen and the basic stuff actually. And then you just go on top of it. You bring all your butter, you bring all your ingredients, and then you prepare it, and and then you enjoy the dosa actually. Similarly, platform as a service, you provide some additional thing, just like you just come in being yeah. So just like you just, in addition to what you give, you can just bring in just bring in the batter, prepare it, and then have it. So that is one parallel I could think of in our real world application. So moving to the other one. So how are we addressing? So I think at the moment we know what exactly the building blocks of cloud computing is, and how are we going to address this using these building blocks to the multi-messenger astronomy? So we talked about in the pre multi-messenger astronomy how the world was, how the space was. They were just using the telescopes, and light waves are used to learn about the objects in the universe. And the computational resources were quite limited. But post MMA, when you see events like a supernova and solar flare, there are a lot of data that is coming in from the astronomy field, and the data growth is exponential in all these messenger signals like light waves, gravitational waves, neutrinos, and cosmic waves. So how are we going to read all these waves? So there are in all the 360 degrees you are getting the data. So we need to constantly read them, try to make some sense out of it, and try to so that it helps in our ongoing experimentation and add value to our studies actually. So that is how it is. So that is where so the need for computation was quite huge because the data volume was huge and the frequency was also huge. So the solution to address the above challenges is what we have: big data, cloud computing, high performance computing, and AI and ML challenges. So how are we going to address these post MMA? How are we going to address using the cloud computing? So let's take a problem statement here. So the gravitational wave signals from the binaries of the black holes and the neutron stars are very weak and fleeting. So finding them requires we need to scan lot of so much volumes of data which are very noisy and they're highly complex. And the few signals will be the signals. It all depends upon the signal strength. If the signal strength is weak, we need to analyzing the signals will be quite challenging. And the solution to the problem, how we are addressing this using the cloud technologies is what we are going to look here. So it's all about, so for example, here we use our cloud vendor as Google Cloud Platform. So we are going to see how Google Cloud Platform is, with their services, they're trying to address this challenge. So the first phase of is data collection. So there are millions of signals coming in from the space. So you'll be having all the sensors, required sensors to collect it, and then you need to decipher it actually. So once the data collection is done, so that is a huge challenge. So with collection of data, you have to have the data. The data should not be lost actually. And how do you transfer the data to the storage system? And that is where the data storage is quite important. And the data storage is quite huge, humongous actually. So there are exabytes of data, and you need to store them carefully. And then once the data is stored in properly, and then there is data cleansing and data preparation. How do you cleanse the data? So you just have to figure out what data is meaningful, what signals are meaningful, what signals are not meaningful. So how do you prepare the signals actually? How do you pre-process the signals? So how do you make some information? How do you tag the signals? Which signals are from neutrinos? Which signals are cosmic waves? Which signals are gravitational waves? So you classify them, you categorize them. So all these things will be really helpful before it goes to the processing. So once you do all these data massaging, data cleansing stuff is done in the data cleansing and the preparation stage of the thing. And then finally data processing, we do once that's where your Hadoop big data clusters comes into picture, and you process millions of signals. And then you just use the data analysis and visualization tools, which are all inbuilt actually. You need not go and procure all these tools. It is all inbuilt today, and the only thing is you just have to get the data and keep moving in. And then you have your data archival and backups. So how much data you need to keep in for your analysis, how much data is required for your experimentation, and how are you going to store the data, when are you going to archive the data, and where exactly your backups are going to be there, and how is your retrieval process. So everything is quite in a phased manner, and this requires a humongous effort to bring from an end-to-end point of solution. But when you come to a cloud technology, everything is there inbuilt actually. Everything is there inbuilt. It's just have to plug and play and do some changes, and you just start your experimentation. So So this is our problem statement, and let's see how we are going to address this problem using the cloud technology that we have. So if you see here, this is the proposed architecture for the solution that we talked about. And the first, if you see that there are sensors which collect the data, and the first phase is about collection of the data, and then the streaming of the data, streaming and the data processing. So you have a cloud pops up is one of the wonderful tool which gets millions of records, and it creates a pipeline to store the data. And once the data is there in cloud, pops up is one of the services from Google Cloud, and then it moves the data to the Google Cloud data flow. So in cloud data flow, what you do is you transform the data, and it's a streaming and batch processing service from Google Cloud. And based on the amount of data that it comes in, it can spin up the number of compute resources, and it can just hold the data together. And it's kind of a messaging, how it in the queue, how the data is messaged and queued to the process is done effectively using Cloud PubSub and data flow. And what they do is they just move all the data to the data lake, is what we create a data lake. And that is where the service called cloud storage comes into picture. And so you have exabytes or petabytes of data, and it has to be very cost effective, because you are going to get millions and millions of data actually. And all these data have to be in a very structured format, how you're going to store the data so that the accessing of the data is easy, and making accessing once you access the data. So once the data is stored in cloud storage and data lake, there are a couple of services like Cloud Data Lab and Cloud Data Preparation. So what they do is they prepare they do the cleansing process, they do the data massaging process, they make the data into a meaningful one. They identify which is the weak signal, which is the strong signal, gravitational signals, and they classify it, and they give more meaning to the data that has come in actually. So these are the two data mining tools which are helpful, which are pretty much used in today's data science projects. And they explore the data, they create different data sets, they try to see what kind of data set is more relevant to the experiment that they're doing today in the scientific world. And then those data sets are separately kept, and it's again stored back in the cloud storage separately. So which is then ingested to the machine learning training process actually. So the machine learning training process, which is the stage 4 here, is used by Cloud Data Lab and Cloud Machine Learning Engine. So they try to understand as you should have learned yesterday that a data lab is all about, meaning there's an iterative process. You have multiple machine learning techniques, uh, uh, um, how do you come up with a well defined model so that it predicts what exactly the data is all about and give informed decisions. So but if you see the left side of the picture, you have a transfer appliance and transfer service. What it does is it tries to collect the existing data from the experiments that the scientists do, and it's kind of a box like a hardware external disk. It collects the data, and then finally it transfers the data to the cloud storage. So in the data lake is what we talk about here. So, and once the data is there in the cloud data lake, it is massaged and processed, and then it is moved to the machine learning models. And from there, it is going to your consumption layer, which is your data mart, and the reporting layer, where the scientists can actually see the informed data. Actually, the more quality data that they can see based on after continuous iterations, based on the algorithms they have in the machine learning model. So you have you have Cloud Bigtable, which uses the big data. You have Cloud Spanner, which is a transactional data which horizontally scales. And you have a BigQuery is one of the powerful tool from Google Cloud, which analyzes the big data, quite efficiently, and it is widely used across the scientific community. And you also have your big data clusters like Hive, Cloud Data Proc, where your data is massaged completely, and it is stored again in the cloud storage, either in the block storages and object store formats. So this is the proposed architecture solution for the challenge that we have in today's scientific world, so that scientists can address the problem and come up with the informed information for their experiments and analysis. So, so these are the main building blocks that we have. So networking is quite. How are we addressing the networking? You have a virtual private network wherein from an on-prem world you can directly to the cloud environment. You create a virtual through the public internet is what a VPN tunnel is created, so that there is a direct communication of data between the cloud world and the on-prem world. But without if you just make a direct pipe, which is called a dedicated interconnect, your data transfer is quite fast actually. So that is quite efficient as well if you have billions and millions of data. But it is little costlier than the VPN channel. When you come to the storage, you have a different type of how the data is getting stored is quite significant. You have different types like block storage and object storage. So that the way the data is stored in these formats help the cost-effective way how to retrieve the data, and based on the use case basis, the different types is being used. And we talked about the security actually. So across the complete life cycle, data is secure with the highest security standards, which Google maintains both in transit as well as when the data is in rest actually. So even the geographical compliance, either the European standards or the US standards or the Asian standards, there are few rules which has to be compliant, and it is compliant so that the data is stored in that specific geography and doesn't go out of that particular geography. So that is taken care with few of the standards that the cloud world has come up with. And computing. So the processors have been evolving on a daily basis as the artificial intelligence and machine learning has been growing on a daily basis. So TPUs are tensor processing units, and GPUs are graphical processing units. They're highly used in machine learning models and big data processing, actually. So the input these compute process they take is humongous, and they just process all the data in no time, and they just give the results. And so when the scientific world, they want to do a lot of simulation, what if scenarios with different data sets that they have, and they wanted to see what exactly the result is, and they wanted to do a continuous iterative experiments. So these tensor processing units and GPUs help. They come in very much handy to them actually. So TensorFlow is one of the very big tool from Google, which is ruling the world today for the AI and machine learning applications. And then, so these are the popular cloud services that we have, like Amazon Web Services and Google Cloud and Microsoft Azure. They are part of your infrastructure as a service. Your IBM Cloud and Alibaba Cloud, they are also into picture. And Salesforce and Oracle are primarily, they are predominant in SaaS applications. And yeah, so these are the major cloud providers, and they're constantly trying to help all the industries across scientific industry, healthcare industry in this COVID times. And a lot of industries, cloud technology is helping different verticals to solve the problems and come up with viable computing solutions. And we have the references here, meaning to understand the different offerings of the cloud world, and how exactly we are helping out this MMA, multi-messenger astronomy. So I think to wrap up, we just started with what cloud computing is, what are the different deployment models, and we saw about what are the difference between the cloud offerings, and what is our exact problem statement today, and how are we addressing using the cloud computing. So that is what it is. And I think most of the faculty members, they can do if they want to do any doctoral, or if they want to do any paper presentation, they can very well take this up, like what are the different cloud providers offerings that can help the scientific community to address today's scientific astronomy MMA problems or MMA challenges that today the field is facing. So that is one wonderful topic that the department can take up, and just come up with different solutions actually. So yeah, so So that will be quite exciting to the whole community. And thank you so much. And with this, I conclude my presentation. Thanks for your patience listening to this lecture. I hope it was helpful. Thank you to the MGR Institute, the team, and thank you, IGL team. Thanks again. Have a wonderful day.
It's me, Dr. Lata. Thank you so much, sir, for having delivered a wonderful talk today. We have been explored with major scientific findings in astronomy so far, like LIGO and TPU. Very nice to hear the cloud computing services and its features with real-time examples as those are serviced at different places. It's very nice to hear, sir. Now, every human knows little about astronomy. Perhaps our earlier childhood days started with a poem like Nila Nila Odiva, and to the first ever rhyme for the child, English rhyme for the child, as Twinkle Twinkle Little Star. And the astronomy never stopped its fascination, and it holds on the grip of human imagination too. But today, we have gained a new windows on universe, and this MMA reveal the universe as never before. Now, I would rather say the science has spread its wings from traditional telescope to multi-messenger technology. Thank you so much, sir, for scaling up our scientific knowledge towards technology. Now, by seeing your presentation, I remember one Tamil Palamoli, மழையிலே பிறக்கும் நார்த்தங்காய்க்கும் கடலிலே பிறக்கும் உப்புவுக்கும் சம்பந்தம் உண்டு அப்படின்னு. So we have traveled a lot from traditional telescope to multi-messenger technology. நம்ம அவை பாட்டி சொன்ன மாதிரி கற்றது கைமண் அளவு, கல்லாதது இன்னும் உலகளவா தான் இருக்குது. அதையும் தாண்டி நீங்க சொன்னதை வச்சு பார்த்தா விண்ணளவாகி போச்சு. Thank you so much, sir, for scaling our knowledge.
Yeah, thank you, ma'am. Thank you, Lata, ma'am.
Sir, there are some questions at the chat box. They are all waiting for your answers. Can we go, sir?
Yeah, definitely, ma'am. Yep, we can definitely take a look at it.
Sir, before looking at the questions, our joint registrar, Sir Dr. S. Nandusamy, has joined our session in spite of the busy schedule to grace the occasion. Sir, please.
Yeah, very good morning to one and all. I'm really very happy that I have been attended this very useful informative session. And on behalf of our management and all the entire team of organization, I really thank Mr. Rajesh who has spent his valuable time in spite of his busy schedule. And one thing I can tell you, this is the right platform to share our knowledge because during this pandemic period, in normal routine life, we cannot share our thoughts and we cannot share our experience for each and every one. So there is FDP is the right platform to share our different experiences. So really, I thank Mr. Rajesh, and I hope that I know something, little bit I know. See, in the earlier days, we were storing the data in the oral thing, and currently we are storing in cloud computing. But unless in current scenario and future scenario, without cloud computing, we cannot store the data and we cannot retrieve the data from nowhere else, including especially in the medical field as well as in the research field. It's a mandatory one. So once again, I thank Mr. Rajesh for giving this wonderful session, and the entire team and the people who have been that is joined in this session. Thank you very much.
Thank you, sir.
Thank you, sir. I'm Dr. Subhashri here.
Yeah,
sir,
thank you
for your presence, sir. Yeah, thank you, sir. Thanks a lot.
Okay, ma'am. Thank you. Have a good day.
Thank you.
Thank you, sir. Thank you so much. Thank you, ma'am. Sir, we'll back to our chat box. How
Yeah.
cloud computing technologies differ from IoT? This question is raised by Swapna.
Yeah, see, cloud computing is Internet of Things is all about the sensors actually. So it's all about the machinery, how you collect the data from your machinery in manufacturing industries. You collect the data using the IoT sensors. So and what you do is both Internet of Things is one of the main thing in cloud computing as well. So you get the data to the cloud comes through IoT sensors actually. So even in one of the proposed architecture when I was showing, so the sensors were there, and there is so the sensors by itself is going to collect the data. So that is Internet of Things, and you have a platform. You have a platform in Google Cloud Platform as well, like IoT Core. So what it does is it is a framework which helps to get the data from the sensors, like telemetry devices like telescope and other devices, scientific devices. It gets the data and then it pushes the data to the ETL engine, and finally that gets stored. So both work in tandem, and there's nothing like it cannot. So Internet of Things is something like the data provider from the manufacturing industry, and the data that has to be processed is there in the cloud, and yeah. So we will be once you get the data, you analyze the data and process it and get some information out of it.
Thank you, sir. Another question that pops is, can you tell more about AWS?
Yeah, AWS is they're the pioneers in the cloud. They were the initial people who just made this cloud computing popular mainly because from the retail industry when the demand was huge, and so that's where they wanted the compute to be. The demand was it was fluctuating in the sense. For example, today if you say Adi Tallupadi, you have huge demand actually, and sometimes otherwise you won't have a demand at all. Similarly, there are some occasions here, so they'll have some. They'll have some deals like for a Christmas or a New Year. So everyone starts buying, and you need to have a lot of compute power. And so for that compute power, so that your information is spent dynamically. So that is where AWS came into picture, and they started the whole cloud computing, and they started taking it to the outside world as well. Initially, they started for their own purpose. Later on, they just shifted as a separate service, and that's how it got popular today actually. And you have a lot of services in AWS. It's phenomenal. You have more than 100 plus services which AWS is offering for the entire industries, for across all the industries they have, and it's quite it's one of the market leader in the cloud computing space.
Thank you, sir. Yet another question. Sir, you have explored about the features of cloud computing and its wonders. What would be the next stage in the cloud computing, sir?
So above the cloud, if you see, it's only sky actually. So so the thing is, see, it's all about the data, ma'am. So you get so cloud computing is just like an infrastructure. So you get data from 360 degrees everywhere. Data is just like a rain. It is just pouring everywhere actually. So you need to have a place to store the data. You need to have a place to process the data, and you need to have a place to just see visually what the data actually means. So for example, today if you see, the whole world is in Zoom actually. Everyone the whole world actually, if you see, they know. So everything is so what is the backbone for it is just cloud computing. So they give the process, they give the processing compute units, they give the way to store the data, they give the connectivity, and so the backbone is there to for you can't imagine actually the kind of processing that you can do. So the big data is, you're talking about the space you're talking about actually. So what today is some it's a gravitational waves. If you just see on top of you, everything is waves actually in the universe. So you want to so how are you going to study the waves in the universe actually? So that's innumerous, right? It's infinite actually. So how are you going to study this infinite actually? So somewhere you need to store something, somewhere you need to process something, and somewhere you need to visualize and analyze something, right? So this is the framework, and this is the computing the platform which helps you to study the whole data in the universe, I would say.
Thank you, sir. Now, sir, I have a specific question to ask you. Being from technical background, now what is that intrinsic motivation you have to inspire others? Because I have gone through your CV where you have told like you like to inspire and motivate the students. So what made you to do so?
So technology is coming with a lot of possibilities, ma'am. So today, with technology, with cloud computing and everything. So today, today's world is we are in a crisis situation today, and everyone is looking for a vaccine today in this COVID situation actually. So how are we going to perform these trials actually? So we cannot just perform a trial just like that, right? So you need to have a lot of data for it actually, and you need to ensure that the human safety is taken care. That is primary for us actually, right? So in that case, so you have data, so technology is helping us to understand this data actually. So how is the data coming from from different factors for different criteria? And when you have data with different criteria and different factors with different dimensions, then you can make some sense out of this data actually. So where exactly this virus would have come from actually? What is the source of this virus? So that way you can change you can help to solve the world problems actually today, whatever the world is facing. So I'm sure technology, if we use it constructively, we can solve most of our problems in today's world. And it's not, and it's just the way we take it to to a rural community or to the youngsters actually. When we make them understand what are all the possibilities that the technology can do, then yeah, they can do wonders, and they can solve all the problems that we have in today's world we are facing, ma'am. So that is something which is interesting me, and yeah, it is exciting me as well.
Thank you so much, sir. Can we take one more question, sir?
Sure, ma'am. Yep, definitely.
What are the security benefits of cloud computing?
So security benefits, I would say. So initially, there was a lot of apprehensions whether to go to cloud. So when you say, so privately, when the data was there, so we had a control over the data actually. So we know it's not going, no one is going to read this data, and we know it's all about privacy, right? So no one is going to steal the data and all those stuff. But that was the main reason where the cloud was not fastly adopted by different industries. But later on, there was a lot of advancements in the industry, like encryption methodologies. If you see, it has grown exponentially how the data is encrypted, how the data is. So even when you're trying to access any private data, any of your financial data, what kind of authentication methods that you're using actually. And again, even the kind of data is getting stored in different regions, geography wise. You have a lot of governing rules to it actually, a lot of compliance standards that you have to meet. And taking all these into consideration, for example, even banks they wanted to get into cloud computing today because that is more viable today actually. So banks, that they don't want their information to be public actually. They wanted their data to be secure. So that is what it's all about, right? So no one wants their data to be sold to the internet, to the public. But there are few. So when all these things are not properly implemented with due diligence, that's where you see news like, okay, this data theft has happened, so these are the number of so all these news comes just because the proper security measures are not taken care, or somewhere there is a loophole where they have not audited properly. So that is one of the main reason. But otherwise, most of the industry, they're moving towards cloud. The reason being is they're very quite confident that they have good security measures to take care of their own data actually. So yeah, so you have a lot of protocols for it, a lot of encryption methods, and a lot of compliance standards to take care of the data, so that the industry is confident and they can move towards the cloud computing.
Thank you, sir. One more question. We'll conclude with that. If what will happen when someone takes MMA as a career? Can we take MMA as a career?
Absolutely, ma'am. So that is so MMA is quite it's quite an exciting subject today. If you see, which has not been explored quite extensively, and it's not in the public forum in a big way, I would say. Because if you see all the scientific experiments that's happening in the astronomic and astrophysics world today, it's phenomenal today actually. So because even last couple of weeks, I think you must have seen the NASA experiment where the two astronauts went to International Space Station, and that was live, and that was the whole world was watching that actually. And so why are they doing so? They're very excited about it. And what are they doing there in the International Space Station? They're doing all these scientific experiments to study about the gravitational waves. There's to study about the neutrinos, to study about the cosmic waves, and everything. So why do you need to study about it? They're trying to go to the next level. What can we do with the what can we do when you go to the moon? What can you do when you go to the Mars actually? So these are the kind of advancements the scientific world is looking up to. So MMA is very much required, so that when you come up with more and more advancements and more refined information, that helps the whole humanity to understand where exactly we are and what is the next step the humanity has to take up to.
Thank you, sir. Thank you so much.
Thank you, ma'am.
No duty is more urgent than that of returning thanks. Let's be thankful to the great hands at work today, for which I welcome Ms. Swapna from EC department.
Am I audible, ma'am?
Yeah, please.
A very good morning, everyone. Thank you is the best prayer that anyone could say. I say that one a lot. Thank you expresses extreme gratitude, humility, and understanding. My sincere gratitude to thank our management, Honorable Founder Chancellor Dr. A.C. Shanmugam Sir, Honorable President Engineer ACS Arun Kumar Sir for accepting to conduct 5 days International EFDP. My heartiest thanks to Vice Chancellor Dr. S. Geeta Lakshmi Ma'am, Registrar Dr. C.B. Parnivelu Sir, Joint Registrar Academic and Admin Dr. V. Cyril Raj Sir, Joint Registrar Engineering and Science Dr. D.B. Jebrat Sir, Joint Registrar Inspections Dr. S. Nallusamy Sir. My special and wonderful thanks to our Dynamic Dean Engineering and Science Dr. N.S. Subhashri Ma'am and Coordinator International Affairs Dr. R. Kausalya Ma'am and all faculty members of Dr. MGR Educational and Research Institute, Chennai. I am happy to convey my special thanks to the resource person, Mr. Rajeshkumar Arjun Raja, for spending his valuable time to share his vast knowledge about cloud computing with his admirable explanation. I extend my gracious to organizing team for their support and all participants. Thank you so much. Begin each day with a grateful heart. Thank you all. Thank you, ma'am.
Thank you, Swapna. And dear professors, I hope you all enjoyed the session. Stay tuned with us for yet another interesting session tomorrow, sharp at 2 p.m. I'll come again. It's 2 p.m. The timing is made convenient for our speaker. Kindly bear with us. Meet you online tomorrow at 2 p.m. Thank you. Thank you, sir.
Thank you so much, madam. Thanks for this wonderful opportunity. Thanks again.
Thank you.